we have started looking at probability distributions, and now we're going to look at probability distribution functions and how we can view these distributions as a function. And let's just recap what a function is. We can imagine the function as a machine where you put things in up here. So in this case, the variable t, and so that's the input, and the output is the function value. So, and we call that f of t. Now, when we talk about these probabilities, we often refer to a random variable, and a random variable. Well, it's random because we don't know what it'll be, so we're talking about random experiments like a dice throw, for example. And t is then just a name for the different results that you can have. Now we use the capital T to describe a random variable, and the lowercase t is the values it can have. So, for example, if we're talking about a 6-sided cubic die, and we call our variable t, different values that t can have is 1, 2, 3, 4, 5, and 6. And we can say that the probabilities that this random variable takes the value of t, that would be the probability for each result. And in this case, it's the same for all 6 sides. But in more complex situations, this doesn't have to be the case. Now, notice that always if this is a probability distribution function, the sum of all the probabilities will always be 1. And the reason we call this a function is that you have a variable t in the first row, and in the second row you have actually the function values when we call this a function. So f of t is the same as the probability that capital T equals the value of t. Now we'll look at one example of a probability distribution function. And here we're asked to show, we're asked to show that the function f of t, which equals t minus 2 divided by 15, and where t has its domain, the domain is defined as an integer, and t takes values from 3 to 7. So what this means is that t can be 3 or 4 or 5 or 6 or 7 and nothing else. So we start off by setting up a table where the different t values that are possible, they would be 3, 4, 5, 6, and 7. So these are the possible t values, and they are defined by the domain here then, that t can be an integer, 3, 4, 5, 6, or 7. And the probability that t can take the value t, we need to find then. And since we have the function, since we have the function, we can just exchange the t in the function with the t value in this table. So 3 minus 2 divided by 15, because here t is 3. In the next one, t is 4. So it's 4 minus 2 divided by 15. The next is 5 minus 2 divided by 15. And the next is 6 minus 2 divided by 15. And the last, 7 minus 2 divided by 15. And we can simplify this and say that okay, we get these fractions down at the bottom here. Like that. Now, if you add all these together, sorry, wrong pen. If you add all these together, you'll find that, okay, this is indeed 15 out of 15 equals 1. And this is how we know that this is indeed a PDF function, a probability distribution function, because when you add up all the possible values, all the possible probabilities, we end up with a sum of 1. And we can also represent this probability distribution in a bar chart with the different values down here. Whereas the 3 has 1/15 chance of happening. The 4 has 2/15. The 5 has 3 and 4. And if you sum up all these probabilities, you get total probability of 1.